All right. So today we're going to look at section 323, which is multiplying and dividing rational expressions. So they're going to give us some nice little fractions. That's what our rational is, right? And we're going to simplify that down. Because these are expressions, we have no idea what they equal, so we'll never come up with an equal something, right? We're just really kind of simplifying these down. Kind of goes, this whole chapter has been like on that equivalent form. So writing that equivalent form would be the same thing as like reducing it, simplifying it, writing it in a different form, all of those good little mathematical concepts we need to make sure we know. So I think we have problems 85, 86, and 87 to do for our notes. And then you guys have some homework problems after that. So review your work from yesterday, or I guess I should say the previous section, by simplifying the rational expression at the right using a giant one. What are the excluded values of x? That is, what are the values that x cannot be? And anytime we have a fraction, we know we have to look at the, what part of it? Right, we have to always look at the denominator, because the denominator cannot equal 0, right? So we have to find values that if we plugged them in for x would make that denominator 0, because we cannot divide by 0, right? So we're going to start off when we look at this little guy. We have two quadratics that are being divided. In order to simplify or to be able to cancel out, we have to have factors, right? And factors are multiplication. You're looking for those parts that are being multiplied together, and they have to match on top and bottom in order to cross out. So for example, like in this one, you cannot just go through and cross off this 11x because it matches on top and bottom. That is totally incorrect, right? So the first thing we're going to do, because the way it's written right now, I can't figure out what's going to make my denominator 0. So I'm going to go ahead and I'm going to factor the top and I'm going to factor the bottom. And then that's going to help me determine what excluded values I need and then how to simplify it even further. So we'll start off with the top. So we're going to do the top. So let's say if we wanted to simplify this, I would suggest probably using like the area model. Right, so we're going to go ahead and jump over to the area model. In the area model, we know we got 3x squared, and we know we have that -4, and we're taking these three terms, and we want to sit there and take 3 and turn it into 4, right? So it's our x values that we are splitting. So this positive 11x, we don't want to write it as 11x. We want to come up with some combination to be able to write it as 11x, right? So usually rule of thumb, we go ahead and we do 3 times -4 is a -12. So in order to get a negative number, one of these has to be positive and one of those has to be negative. And then we need to find our factors for 12. So to get to 12, we either have 1 times 12, 2 times 6, or 3 times 4. And that's where this 11 comes in handy. So we're looking for numbers. One's positive, one's negative. So technically when you subtract the numbers, they're going to get you to 11. So this one gets you to 11, this one does not, and this one does not. So we know that it has to be the 1 and the x. And since it's a positive 11, we know that it's got to be a positive 12 and a -1. So now we're going to figure out our factors. So I'm going to start in that upper left corner. So to get x squared, I know I need at least an x and an x. And then I got to be able to multiply to get to 3. And the only way I'm going to get to 3 is a 1 and a 3. So I need to figure out if I want to do my 3 here and my 1 here, or if I want to do my 1 here and my 3 here. So that's the question. So this is where we have to look ahead a little bit. And I like looking for these 1s, because if I put a 3 here, right, so then now I have 3 times what is going to give me -1. Well, technically that'd be -1/3, and we don't want a fraction. So that's kind of my indicator that my 3 is not going to go on the top, my 3 is going to go on the left. So I got my 3 here. And then I'm just going to kind of start working around the clock to fill in my mixing little pieces. So x times what is going to get me negative 1x? I still need my negative 1. You get one more to fill, right? So 3x times what is going to get me to 12x? 4. And a positive or a negative 4? Yep, a positive 4. And I just throw it in there. I think it makes it a little easier because then now you can really see your factors. And then I just always double check. 4 times negative 1, negative 4. Yep, so I should be good to go. So I know that my numerator, my part on the top, is going to factor into x plus 4 over, and I know I'm going to, whoops, sorry. So I know that my numerator is going to factor into x plus 4 over 3x minus 1. And now I just need to factor my denominator. So I'm going to take this guy, I'll throw him over here. So again, to me it's not, you can't factor it really easy by doing kind of that FOIL method of figuring out those two parentheses. So I'm going to jump right into using that area model. I have my 2x squared. I know I'm going to have an x and x that I got to figure out. And then my bottom is going to be 12. And I don't know about that red on the screen. We're going to finish it for this problem, but I think I might be changing that color. So again, I'm going to look back at my original, and I have 2 times 12 is 24. So I need to come up with, and it's a positive 24. So the only way that I can get positives is if my x's are a positive and a positive, or a negative and a negative. And on this one, that positive 12 is going to tell me that it's got to be a positive and a positive. So now I'm going to figure out my factors of 24. So 1 times 24, 2 times 12, 3 times 8, 4 times 6, no 5, and then we're right back to where we are. So now I'm looking for, when I add these x's together, it has to equal 11. So that one's not going to work. That one's not going to work. Oh, but looky there. 3 and x is going to work. And it doesn't matter where I put the 3 or put the x or the 8, so I'm going to put the 3 here. I'm going to throw the 8 down there. Either way, doesn't matter, right? So now I need to figure out what I multiply to get all of the little rectangles inside. So I'm going to start in that upper left again. To get x squared, I know I need an x and an x. And so again, when it comes to my 2 can go here, or my 2 can go, whoops, or my 2 can go here. So I just gotta pick and choose. If I put my 2 here, I need to find 2 times what is gonna give me 3. No fun. So I'm gonna put my 2 up on top. So I got my 2 on top. So I'm just gonna start moving around. 2x times what is gonna give me 8x? Yep, you said it. Positive 4. What times x is going to give me to 3x? Positive 3. And then I'm just checking that last one. Positive 3 times positive 4 gives me a positive 12. So now in my denominator, my factors are 2x plus 3 and x plus 4. Right? So before I go any further, I want to find my excluded values. So my excluded values are values that's going to make my denominator 0. So since these two little guys are multiplied together, we know that either 2 2x plus 3 can equal 0, and x plus 4 cannot equal 0, right? Solve these babies for x. I'm going to subtract 3 from both sides. I'm going to get x equals, 2x equals negative 3. Divide by 2, x is going to equal negative 3 halves. And then I'm going to subtract 4, x equals negative 4. So my excluded values, x cannot equal negative 3 halves or negative 4, right? So that's part of my solution. And then the other part is looking at my factored rational expression to see if I have anything that matches on top and bottom that's a factor. Factors are what's multiplied, so we want to see what parentheses match up exactly. And I can see that my x plus 4 and my x plus 4 match up. My 3x minus 1 and 2x plus 3 completely different. So simplified form is going to be 3x minus 1 over 2x plus 3. So make sure you're including both of these pieces. Okay. All right. Problem 86 with your team. I'll be your team if you'd like. We need to review your responses from your homework on problem 82. Verify with everyone that everyone obtained the same answers, and be prepared to share with the class how you multiplied and divided the fractions below, right? So we already kind of worked on these problems, so we're just going to kind of go through my thought process. My thought process could be different than your thought process, but I'm going to give you mine, right? So for that first one, we have 2/3 times 9 over 14. When we're multiplying fractions, we're multiplying those babies straight across, right? So this would have been 2 times 9 over 3 times 14, right? And then if we wanted to, we can simplify that down even further. 2 times 9 is 18 over 3 times 14, which is 42, right? And then we can work on reducing that down into simplest terms. The other way you could approach this problem is you have your 3/9 times, your 2/3 times your 9 over 14, and we can cross reduce. We know that 2 goes into 2 once, 2 goes into 14 7 times, 3 goes into 1, 3 goes into 3 once, 3 goes into 9 3 times. Now we have 1 times 3 over 1 times 7, which is going to give us 3 over 7. Right. On the second one, we have 3/5 divided by 12 over 25. When we are multiplying fractions, we are I'm having a rough day with my language, aren't I? When we are dividing fractions, we are multiplying by the reciprocal. So to multiply by the reciprocal, we get 3/5 times the reciprocal, you're just flipping it over, 25 over 12. And then now you're right back to a problem like this. And then you can make your choice if you either want to multiply it all out and then reduce it to where we know that on this one, 6 goes into both of these, so you're dividing these both by 6, and you're getting 3 over 7, right? Same answer as the one below. So whichever method you want to use, whichever one you're more comfortable with, this one or this one, when it comes to finishing this problem. All right. Problem 87, they gave us a whole bunch of problems to look at. We're going to kind of pick and choose a little bit, right? So use your understanding of multiplying and dividing fractions to review the expressions below. Then look for giant ones and simplify. Those giant ones is what I refer to as those factors, right? And simplify. For each rational expression, also state any values of the variable that would make the denominator 0. So those would be those excluded values. Okay? So when we look at number 1, like I'm not going to do all 6 of these. Letter A, not number 1. A is a lot like what we were doing up above, kind of in some of those examples. We're multiplying these together. So if it makes it easier, once you see this, you can either see that those x minus 5s are exactly the same and cancel those out, or if it helps, you can write it all as one fraction and then just use some parentheses. So this would have been 4x plus 3 times x minus 5. And then in the denominator, x minus 5, x plus 3. Right? So when it comes to my excluded values, I guess I should have wrote this below, huh? We'll just call it our EVs. Excluded values. We know that our denominator can't be 0. So if I put in a 5, that would make it 0. So we know x cannot equal 5. And then on this one, that would be negative 3 would make it 0. So we know that x cannot equal negative 3. So then now you can simplify what parentheses or giant ones, aka factors, match up exactly that x minus 5 and that x minus 5. So then you're left with 4x plus 3 over x plus 3. So you get that in your excluded values. Guess I did it for you anyways, huh? On B is pretty much the same kind of concept, except for you have to make sure you're paying attention to your operator, not the lady that you used to call on the phone, but your mathematical operator. You can laugh, it's okay. I know it's funny. It's okay. Except for that we're dividing, and since we're dividing, we are multiplying by the reciprocal. So you would have that original x plus 2 over 9x minus 1, that first rational expression. And then now you're going to multiply by the reciprocal, which is 9x minus 1 over 2x plus 1. Right? Find those excluded values. Find our excluded values. And then you can cancel those factors or giant ones, right? And then you're good to go on that one. Look at, I repeated this like over and over again. Then I don't even use the space I provided myself below, right? On letter C, we have 2m plus 3 over 3m minus 2 times 7 plus 4m over 3 plus 2m, right? So on this one, like they're just trying to give you some scrambled up kind of problems a little bit, trying for you to figure out all of those similar or those equivalent expressions. So normally we love it when we write these guys in standard form, which is where we have like all of our variables and then our constant term, right? We got our variable and our constant term. But on this one, they sat there and they switched it around on us because they are trying to be a little tricky. That's all it is. So honestly, I would rewrite these. So I would have the 2m plus 3 over 3m minus 2 times, and then rearrange this one. All you're doing, like technically, this is a positive 7 and this is a positive 3. So you can just take those numbers and switch them around. So if I write my 4m first, and it's a positive 4m, so it's just 4m, and it's a positive 7, over, I have a positive 2m and a positive 3. And then now it might make it easier when we look at these two guys. Look at those two. Now they match up perfectly. Sometimes when it's written this way, it's kind of hard to see that those are exactly the same thing. So once you rewrite it, then it makes it a little bit easier. Same thing, you're going to find those excluded values. right? You're gonna give me that, baby. And then you're going to simplify it as much as possible, and then, you know, simplest form. I'll just write that on there. And then give me that part of it. Sound good? D, they just kind of, like I said, they're just making it a little bit more fancy. So on D, they're giving us y minus 2 to the third over 3y times y plus 5 over y plus 2, y minus 2, right? So what does on this y minus 2 to the third mean? It means you're multiplying it out 3 times, right? So if it helps, do a y minus 2, a y minus 2, and a y minus 2 all over 3y times y plus 5 over y plus 2, y minus 2, right? Again, you still got to find those excluded values, and then you can sit there and see if there's anything that you can simplify. And you're looking, they have to match up perfectly. So there's no 5y in the denominator, but there is y minus 2. There's one y minus 2 and a y minus 2, or whichever one you pick. You can only cancel one of those out because there's only one in the denominator, right? So then those guys would cancel out, and then you would be simplifying it down farther. On C, we have 15x to the third over 3y divided by 10x squared y over 4y squared, right? So if we are dividing, we're multiplying by the reciprocal. So we would have 15x to the third over 3y times, now in the numerator would be 4y squared, and the denominator would be 10x squared y. So we're going to find those excluded values. And we have 2 variables now in the denominator, don't we? You technically have to go through on every single step to figure out what would make your denominator 0. So on this one, I kind of skipped it for a second just because we know it's going to be y equals 0 because of these guys being multiplied together. So I knew I was going to pick it up here, so I kind of waited. So my excluded values, we know that x cannot equal 0, right? Or sorry, we don't know about x yet. I haven't talked about x. I don't know my letters today. We know that y cannot equal 0. And then now when we go and look at this little guy, this is the one that's got the x in there. And that x is right there and it's being multiplied. So we also know that x cannot equal 0, right? So those are our 2 excluded values. Now we can go through and simplify. And again, you can put this all together as one numerator and one denominator, or you can leave it where it is and kind of simplify it from here. So I would probably, let's look at this first piece, and I'm looking at my 15 and my 3. I know 3 is going to go into 3 once. I know 3 is going to go into 15 5 times. For whatever reason, I like to start off with my whole numbers and then look at my variables. And then when I look at 4 and 10, I know that 2 is going to go into both of those. 2 is going to go into 4 twice. 2 is going to go into 10 5 times. Right? And then now that I reduced it, now I sit there and I'm like, oh, look at there. I have a 5 in the numerator and a 5 in the denominator, so guess what I can do? Those 2 simplify each other out. And then this is where it kind of gets a little complicated if with leaving your fractions separate when it comes to being able to cancel out your variables. So right now I have x to the third in the numerator, and in the denominator I only have an x squared. So that means I can only cancel out the one that I have the least amount of. So I have 2 of them down here, so I can, these 2, and there's 3 up here, I can only take out 2 and 2. That looks really sloppy. So I can cancel this whole guy out, but on this guy, I'm going to be left with an X. I don't know how to. Because I can only take 2 of them away, so I'm going to be down to X to the first. And then when I look for my Y's, I have Y squared. So I have a Y here. So I can cancel off one of these Y's with this guy. But I have another Y over here, and that other Y allows me to cancel these guys out. So what am I left with on top? I'm going to look at the top part, and it looks like I have a 2 and an X. So I got 2X. And then in my denominator, I think everything ended up getting canceled out. So you can put it over 1 if you want, or you can just put it over 2X. Right? And then on E, oh sorry, that was E. Told you I'm having a hard time with my letters today, aren't I? On F, F, they actually went through and there are a whole bunch of factors. You do have that square there, so if it helps out, you can leave it this way, and like when you go to cancel, like know that you can only cancel one of those out, so like your squared would go away, or write it out twice so you're canceling the ones out. On this one, the biggest thing is making sure you're looking at your operator, so you're multiplying by the reciprocal of that whole entire rational expression over here. You have to do the reciprocal, flip everything over, and then you can cancel out those like terms, find those excluded values. Alright, that's all I have for notes for today, and then you guys have some problems to work on your assignment.